Collisions mechanical physics. Number 1. Perfectly elastic collisions. The amount of the moment is preserved. The amount of kinetic energy is conserved. If the amount of initial move is equal to amount of final move, and also the amount of kinetic energy and the begin and they are equal. So it's perfectly elastic collision in a perfectly elastic collision. The total kinetic energy before and after the collision is conserved. This means that, unlike in elastic collisions, there is not the transformation of kinetic energy into other form of energy, such as air or strain. In addition, Baudelaire moments and kinetic energy are conserved in type of collisions. A common example of a perfectly elastic collision is the collisions between bars on a pool table. In the case, the total kinetic energy of the bash before impact is equal the total kinetic energy after impact. Number 2. Inelastic collisions. In elastic collisions, the amount of move is conserved, but the total kinetic energy is not. This means that the speed and direction of objects may change, but the sum of train moments before and after the collision is the same. During the collision zone of the kinetic energy is conserved into internal energy of the system, such as its zone or the form of object. Inelastic collisions are common in everyday situations, such as in car accident or billiard crashes. Number 3. Perfectly inelastic collisions. A perfectly inelastic collision is a special case of inelastic collision in which objects come together after impact and move together as single mass. In the type of collision, the maximum amount of kinetic energy is transformed in the other forms of energy, such as heat, sounds, or waves. A common example of perfectly inelastic collisions is when two cars collide and become joined together after impact. This type of collision is important in physics and engineering as its help is understand how objects interact in impact situations.